Hello and welcome everyone. This is Chris, and today we're going to have a look at the energy consumption features in KUKA.Sim that has a huge impact on the total cost of ownership, or TCO, from your robot, as you can see on this pie chart from the automotive industry over 14 years. So for that we have a demo layout. It's called Pallet Save Energy. You don't have to build it up by scratch to reproduce what we're doing today. We will first click on the robot and then go to the Program tab. And here we're going to go to the right where we can see our trace features and first collect the data. Then we can also select the trace settings so that we have the settings here on the right side, and also click on the trace diagram, which will open a new window here on the bottom of the simulation view. If we now click on play the simulation, you will see the trace functionalities as you already know. So at the moment we're looking at the axis position, but we want to first analyze the power consumption, and in this channel 2 we want to analyze the energy consumption. And if you now have a look at the diagram, you will see some peaks of power consumption in pink and the sum of it in this yellow dotted line. At the same time, you will see the robot move and see how it carries these little boxes from the conveyor to the left side where there is the pallet, and then places them there. And if we comes back to this end of the simulation, we will see that the energy consumption here is about 28.7 watt hours. Please take that values as qualitative values. They can change with a real controller and a real robot. If we have a little calculation right now, this is what is shown here on the left. Or one layer for the pallet takes about 40 seconds, so that's the 37.7 seconds that we can see here. This means that 6 layers will take 240 seconds, and we will pallet about 15 pallets per hour at this rate. And so if we now see that our energy consumption actually is about 29 watt hours, this will mean that it requires 174 watt hours for one whole pallet. And then if we have 15 pallets per hour, this will equal 2.6 kilowatt hours. Now you can take those values and multiply it by the opening hours that you have in your production and by the cost of 1 kilowatt hour in your country or in your production site. With that, you can calculate the total cost of ownership regarding the energy consumption over 10 or 20 years. Now is the question, how can we optimize that in the simulation so we don't have this high energy consumption on the shop floor, but we can reduce it in the simulation first. The first part, or the first step, would actually, you saw that the pallet is very far away from the conveyor, so we can adapt our layout. Let's click on our pallet, click on move, and move it a little bit to the right, so closer to the robot. Let's do the same thing for the conveyor. Let's move it a little bit to the left of the robot, so that actually it's closer to the robot. Now remember this 28.7 watt hours. We'll just see what happens if we pallet the 4 boxes now, the one layer. Let's see, the first one comes in. I'm going to speed up a little bit the simulation so that we get to the result a little bit faster. Awesome. Now let's check out the energy consumption here. We at 22.8, so about 23 watt hours, which is already a huge reduction, about 20% of the total energy consumption just by adapting our layout. Now we want to change the load data. For that, we reset our simulation and go to the jog manipulation mode of our robot. Then go to the right side where we have the tool settings and go on the little gear for our tool 1. Currently we have the -1 written in the mass. That means that the robot calculates everything with the maximum payload of, in this case, 120 kilograms. We want to change that. Maybe our box has only 36 kilograms in total with the gripper. So we're going to change that to 36 kilograms. And we're also going to add a little center of gravity value here. So maybe it's going to be 30 millimeters on X and another 20 on Y and 90 on Z. And in addition to that, we are going to set some inertia because that's also very important for the calculation. In this case, we will have 0.3 and 0.5 in the inertia values. And now let's try again and see what happens. So again, I have the simulation accelerated, so this is a little bit faster. We result in an energy consumption of about 21 watt hours. So a drastic reduction of the energy consumption, almost another 10% of energy consumption from the previous step. Now would be the question, what can we do else? You saw that the robot program is very choppy. So at the moment we're not using continuous movements, and this is what we're going to do right now. So I'm going to go into my program and select every post or pre-position that we have. In total this are these 5, so I don't want to use the pick and drop positions, but all the others I want to set them to a continuous movement. So I will set this blending statement to standard and with an approximation distance of 500 millimeters as a default value. Let's check out what the robot does now. First we can see that the energy consumption is a little bit less choppy here. The pink curve is not so steep. And if we have now a look at our program, in the end we will consume only 18.47 watt hours. We'll get an improvement of about 15% just for this robot by actually adapting my program. We have now 25.8 seconds and we said we only need approximately 40 seconds for the robot to do the task of one layer. We are way too fast at the moment with our continuous movement, and we can drastically reduce the speed to again reduce our energy consumption. With Shift I select all our points, and with Control I can deselect our other statements, and I will now reduce the velocity of these PTP movements to maybe 40% and also reduce the acceleration to about 40%. And now if I reset the program and play again, we will see that the robot moves a little bit slower, but it's fast enough to reach our goal of 40 seconds. Here we go. So at the end we are now at 36.89 seconds, but we reduced the energy consumption by the half of it. So we are again only at 10.3 watt hours, which is a drastic reduction of our energy consumption. And like this, by improving your layout step by step, you can really see that the energy consumption is visibly going down. The delta is huge. You can improve your programs up front before going onto the shop floor with your prepared program. And so check this total cost of ownership before getting started on the real shop floor.
Thank you for watching this video. If you would like to see more interesting videos about KUKA Simulation World, feel free to hit the like button and subscribe to the channel. Looking forward to seeing you in the next video.
Industrial intelligence.